Hi everybody, Mrs. White here. I wanted to take the time to give you a little introduction and mini lesson that will help you get a better visual for the direction that we're trying to go for our next few lessons. What we'll be working toward is building a powerful trigonometric tool called the unit circle. And what you're looking at in front of you here, this is also what you'll see when you open today's packet. What you're looking at here is the unit circle, and our work is going to be to notice some patterns and make some connections that will ultimately allow us to fill in everything you see set up for you here, which would include the degrees of every angle as we move around the circle, the radian measures of every angle as we move around the circle, and then also some coordinates that mark certain landmark locations, some special locations as we move around the unit circle. So over the next couple of lessons, we'll be looking at how we can go about basically filling in this whole circle so that by the time we're done, you have everything labeled. Okay, today we're just going to focus on the degree measures and the radian measures. So we'll just be focusing on angles today. We'll save thinking about these coordinates for the next lesson. So before we get started, let's look at what we know so far about the unit circle. In a previous lesson, you learned that the unit circle is called the unit circle because the radius of the circle is 1 unit. That will become important in our next lesson. For today, we're going to need this basic convention here that shows how the unit circle is defined. And so the unit circle is defined so that 0 degrees starts over here on the positive x-axis, and as we rotate counterclockwise, we are getting bigger. So we're adding and the angles are getting larger and larger. That's the positive direction. If we move clockwise, we're actually going backward. So the angles would be getting smaller and smaller, even negative. That would be defined as the negative direction. So again, zooming back out, over here is where I placed 0 degrees. If we go all the way around the circle, that would also be 360 degrees. And we'll take a closer look at those ones I already have labeled in just a minute here. As I move counterclockwise, I should see the angles getting bigger. If I were to move clockwise, I should watch the angles get smaller by the time we have this whole circle filled in. So you'll notice that on this first page, I already have 4 of the locations filled in for you. But I want to take a closer look at where those came from, because the thinking is going to help us then be able to get to the other angles that we're seeing on this circle. So on the second page of your document, you'll see those 4 angles that are already filled in for you. And I'm going to call these the 4 corners. It's basically the 4 locations that actually sit on the axes. So we've already talked about how 0 degrees is defined as our starting point. So then if we go, and we know that if we go all the way around a circle, that would be 360. Well, half of that is 180, so that must mean if we've gone halfway around the circle, that's 180. And then we can do even better than that. We can say, well, if 180 is halfway around the circle, and the y-axis essentially cuts that into 2 equal parts, then 180 divided by 2, which is 90, must be the degree location as we sit up top. In other words, we can see this 90 right here. We've rotated 90 degrees counterclockwise to land up on top of this circle. And now I can essentially count my way around. I can start over here at 0 and I can add 90. And then I add 90 again and there's that 180. And then I add 90 a third time and sure enough there's 270. And if I add 90 yet again, I'm at 360. I could even move backward. I could start at 360 and subtract 90. That would get me backward to 270. You can really work your way around the circle in any direction you want, but we want to be aware of how much we're adding or subtracting as we move around. Okay, so there's our 4 degree locations for what I'm calling the 4 corners. Okay, now let's think about what that would look like in radians. So in order to do that, we've got to think about this other thing that we learned in a previous lesson, that 180 degrees is equivalent to pi if we're in radians. So I can come over to my circle here now and say, well, I know that 0 starts here. So then halfway around the circle, 180 degrees must be pi in radians, which means if I go all the way around, I'm doing twice that much. 360 degrees is therefore equivalent to 2 pi. So I now know that 180 is pi, so doubling that, 360 must be 2 pi. Well, now I can use the same thinking I did over here, that 90 is halfway to 180, which must mean up top here is halfway to pi. So I can think of it that I have 180 degrees, which is pi radians, cut into two equal parts, which must mean pi divided by 2, or pi over 2, is the equivalent of 90 degrees. And you could check that by replacing the pi with 180. 180 divided by 2, sure enough, is 90 degrees. And now I can kind of use that same counting method. Over here in degrees, I started at 0, and then I added 90, and I added 90 again, and I added 90 again. I can do that here, but I'm using pi over 2 this time. So I'm going to count, and I'm going to say this is 1 pi over 2, which must mean this is 2 pi over 2, which makes sense because 2 pi over 2 is pi. And now I can keep going. Next would come 3 pi over 2. There's my 270 degrees. And then I could do it even again, and I'd get 4 pi over 2, which again makes sense because 4 pi over 2 would reduce to become 2 pi. And thinking of pi as 2 pi over 2 is a helpful thing. It allows me to more easily get backward and forward to these radian measures that are a little harder to think about. So if I think of this as 2 pi over 2, I can move backward to get to pi over 2. If I think of this as 2 pi over 2, I can move forward to get to 3 pi over 2. I could also get that 3 pi over 2 by moving backward from 4 pi over 2, and that would land me on 3 pi over 2 again. So as we move forward with this lesson, we're going to really keep thinking about moving forward and backward from the x-axis to get to these other special landmark locations. So you'll see if you look back at the main unit circle that I already have those 4 corners located for you, labeled with degree measure and also radian measure. Let's take a minute now to focus on these 4 blue dots that you see, the 4 locations that are halfway through each quadrant. So if you scroll in your document, or just follow me for now, and look at the second work page, what you see here is a page titled Reference Angle equals 45 degrees. So let's think about where that 45 degrees is coming from. If we know that half a circle is 180, and if we look at the top of this circle, it's divided into 1, 2, 3, 4 equal parts. So we can think of it that the 180 is cut into 4 parts, or in other words, 180 divided by 4 is 45. Let's do that same thing in radians now. We know that halfway around the circle in radians is pi. So I can do that exact same thing and say I'm taking pi and cutting it into 1, 2, 3, 4 equal parts. And so the radian equivalent of 45 degrees must be pi over 4. So I'm expecting when I end up with radian answers for these 4 special locations that it's going to be some multiple of pi over 4, because all of those spots are some multiple of 45 degrees. So now let's focus for a minute on something called a reference angle. This is going to be the key that makes this whole unit circle start to feel like one big pattern. The reference angle is defined as the angle with the x-axis. So if I look over here at my first circle, I can think of this location right here as being 45 degrees above the x-axis. This location over here is also 45 degrees above the x-axis. And then these 2 down in quadrants 3 and 4 are 45 degrees below the x-axis. So all 4 of those spots have a reference angle of 45 degrees. I can think the same way in radians. The only difference is now I'm using radian measure. So this angle is now pi over 4, which means this is pi over 4 above the x-axis. This is pi over 4 above the x-axis, and these 2 would be pi over 4 below the x-axis. It's that angle formed with the x-axis we're talking about when we talk about reference angle. So let's see how we can use that to help us easily come up with the degree and radian measures at these 4 special locations. So let's think degrees first. Our brains are a little more used to degrees, and so we'll start with what we know and understand. So if I know this is 0 degrees, and I know that moving counterclockwise gets bigger or adds, I can just take 0 plus 45, and now I know this must be 45 degrees. I can come over here to what I already know is 180 and say, oh, this time I'm moving backward. I'm going clockwise. So now I'm going to take 180 and subtract 45 to go smaller, which would tell me that this is therefore 135 degrees. I can also start at 180 and go bigger, because as I move counterclockwise, I'm actually getting bigger. So to get this angle in quadrant 3, I can start at 180 and add 45, and that would give me 225 for this spot right here. And then finally, I can even quickly get this last location if I think of it as that 360 was all the way around, but now I'm going backward to get here. So I can take that 360 and subtract the 45-degree reference angle. 360 minus 45 would tell me that this angle right here must be 315. When I come over here to radians, I'm really doing the same thing, but now I'm thinking in radians and using the idea that 45 degrees is equivalent to pi over 4. So when I look at this picture here, starting at 0 and adding pi over 4 puts me at pi over 4. Common denominators will be real useful when I come over here. I know that this is pi, but why not think of it as 4 pi over 4? Because then I have this common denominator of 4. 4 pi over 4 is pi. But if I think of this as 4 pi over 4, now I can move backward. 4 pi over 4 minus pi over 4 gives me 3 pi over 4. Or I can start at 4 pi over 4 and move forward, which gives me 5 pi over 4 for this location in quadrant 3. And then I can even do that when I get over here to the 2 pi. If I want my problem to be in fourths, why not think of 2 pi as 8 pi over 4? That is 2 pi after all. And now I can move backward. 8 pi over 4 minus 1 pi over 4 would leave me with 7 pi over 4 over here in quadrant 4. So again, I've got this reference angle of pi over 4, and I can always think of it as moving forward or backward from the x-axis to land on that location halfway through each quadrant. You'll notice when you go to your main circle that I did not yet label those radians and degrees for you. So why don't you go ahead and start off by filling in the degrees and radians for those 4 middle locations in each quadrant. The rest of your task for today is going to be to try to use the same thinking we just did right here for 45 degrees, but to do it for the other 2 sets of special locations. So the next one I'd like you to consider is 60 degrees. We can really do the exact same thing where we start off and say, well, this is 180, but it's being cut into 3 equal parts. So I'm going to take my 180 and divide by 3. In radian world, I would do the exact same thing, but now I'm thinking about pi as halfway around the circle. So that would be pi cut into 3 equal parts. Or in other words, pi over 3 radians. So now I know that these spots on the circle that are farthest away from the x-axis are actually 60 degrees away, or in radians, pi over 3 away. I put a few hints on here to get you started, but your job for today is going to be to try to now use that same repeated reasoning that we used for the 45-degree angle to come up with the locations in degrees and radians for these 60-degree reference angles. And then there's one more page where you can essentially think through that reasoning process one more time, but for that 30-degree angle. These are the 4 spots that are closest to the x-axis when we look at our 4 quadrants. So your task today is to try to work through these work pages and then go back to your main circle. By the time you're done today, you should have the degrees filled in for the entire circle. You should have the radians filled in for the entire circle. You can save the coordinates for the next lesson. We'll look at those together next time. So just leave the coordinates blank, and that also means on these pages you can leave the coordinates blank for now. We're going to need to learn a little more and think about a little more to be able to get to those coordinate locations. So have fun, and we'll check back in next time to see how you did.